RTX opened a new frontier for computer scientists, and a flood of new algorithms have appeared. A new era of RTX neural rendering has started. Today, we're announcing Ada Lovelace, our third generation RTX. One Ada GPU powers Racer X. This generation is named after mathematician Ada Lovelace, who is often regarded as the world's first computer programmer. NVIDIA engineers worked closely with TSMC to create the 4N process, optimized for GPUs. This process lets us integrate 76 billion transistors and over 18,000 CUDA cores, 70% more than the Ampere generation. Ada evolves all three RTX processors. First, a new streaming multiprocessor with 90 teraflops, over 2 times the previous generation. Ada's SM includes a major new technology called shader execution reordering, which reschedules work on the fly, giving a 2 to 3 times speed up for ray tracing. SCR is as big an innovation as out-of-order execution was for CPUs. Second, a new RT core with twice the ray triangle intersection throughput, and 2 important new hardware units. A new opacity micromap engine speeds up ray tracing of alpha test geometry by a factor of 2 times. And a new micromesh engine, which increases geometric richness without the BVH build and storage cost. And third, a new tensor core with the Hopper FP8 transformer engine and 1.4 petaflops of tensor processing. Raw ray tracing horsepower is not enough to ensure high frame rates. Ray tracing is notoriously hard to parallelize because rays bounce in every direction and intersect surfaces of various types. GPUs are highly parallel and most efficient when processing similar work at the same time. Ray tracing workloads lead to different threads processing different shaders or accessing memory that is hard to coalesce or cache. Shader execution reordering, SER, improves execution efficiency by rescheduling shading workloads on the fly to better utilize the GPU resources. We're seeing up to 2 to 3 times increase in ray tracing and 25% in overall game performance. Like accelerated computing, computer graphics is a full stack challenge. Breakthroughs require innovation in architecture and design, as well as algorithms. For example, NVIDIA's RTX GI uses ray tracing to do real-time multi-bounce indirect lighting. RTX DI uses ray tracing to do direct illumination from millions of lights, casting shadows from all lights. RTX DI is used for emissive surfaces, such as billboards, TV screens, neon tubes. NVIDIA real-time denoisers is a spatial temporal denoising technique that takes an incomplete ray-traced image and infers the ground truth, reducing the number of rays needed. And DLSS, Deep Learning Super Resolution, is one of our greatest achievements. Ray tracing requires insane amounts of computation. Each frame of a CGI movie takes hours to render. We want to do this in real time. NVIDIA RTX opened the world to real-time ray tracing. RT cores do BVH traversal and ray triangle intersection testing, which saves the SMs from spending thousands of instructions on each ray. But even with RT cores, frame rates were too low for games. We needed another breakthrough. Enter deep learning. DLSS uses a convolutional autoencoder AI model and takes the low-resolution current frame and the high-resolution previous frame to predict on a pixel-by-pixel basis a high-resolution current frame. The AI model is trained to predict an ultra-high-resolution 16K reference image. The difference between the predicted and reference image is used to train the neural network. The process is repeated tens of thousands of times until the network can predict a high-quality image. Ada introduces DLSS 3, a new AI that generates entirely new frames rather than just pixels. DLSS 3 has 4 components: a new optical flow accelerator, game engine motion vectors, a convolutional autoencoder AI frame generator, and our reflex super low latency pipeline. DLSS 3 processes the new frame and the prior frame to discover how the scene is changing. The optical flow accelerator provides the neural network with the direction and velocity of pixels from frame to frame. Pairs of frames from the game, along with the geometry and pixel motion vectors, are then fed into a neural network that generates the intermediate frames. DLSS 3 generates entirely new frames without processing the graphics pipeline, boosting game performance by up to 4 times over brute force rendering. Because DLSS 3 generates a new frame without involving the game, it benefits both GPU and CPU limited games. For CPU limited games, like physics heavy or large world games, DLSS 3 allows the Ada GPU to render the game at a much higher frame rate than the CPU is able to compute the game. DLSS 3 is one of our greatest neural rendering inventions. Here is Cyberpunk 2077, shown in all new max ray tracing mode with SCR and DLSS 3. Pushing the state-of-the-art graphics into the future takes an incredible amount of computational horsepower. In a modern game like Cyberpunk, we run over 600 ray tracing calculations for every pixel just to determine the lighting. That's a 16 times increase from the time we first introduced real-time ray tracing 4 years ago. Yet the number of transistors we have available in a GPU to do these calculations have not increased at that rate. That's the power of RTX. We can deliver a 16 times increase in 4 years with artificial intelligence. Some pixels are calculated, most are predicted. Let's enjoy Microsoft Flight Simulator, a game that is CPU limited because of the realistic physics and the giant worlds. It is one of the longest running franchises. This is Flight Sim's 40th anniversary. With Ada and DLSS 3, Flight Simulator is silky smooth.